In the last episode, we got Python installed and running. Now, let's use it. In this episode, we'll look at small programs that do something, then pull them apart piece by piece. By the end of this episode, you'll understand variables and types. You might even see a few things that surprise you. Okay, let's make a sample program. I'll create the notebook as we go along here. So here we have I guess the name of the thing. Names, values, and types. Let's make another markup cell. Let's call this sample program. Okay. So as you can see, these cells are code by default. So let's make a program. Name equals input. Yeah. What is your name? So we'll see when I run this in a moment, but this will give me an input box, and there'll be a phrase next to it that is, what is your name? And then the input box, and then I'll type in whatever that is. Okay, age is also an input box, and this one will say, how old are you? There we go. Seconds. So the seconds I've been alive, age times number of days in a year, number of hours in a day, minutes in an hour, number of seconds in a minute. And then I'll say print hello name. And then you have lived for approximately however many seconds. This is the variable that we just calculated. And then I'll have the word seconds. So if the answer is 100, it will say you have lived for approximately 100 seconds. Okay, and let's run it. What is your name? So that's from line 1, the input box. What is your name? Okay, and Mark is now the value of the variable name. How old are you? 29. Been 29 for almost 30 years. I have lived almost 1 billion seconds. Look at that. One thing I want to flag, I'll come back to this, but in line 2, there's the input, how old are you? And I typed in a number, and then there's something with an integer that's wrapped around that. So I'll come back and explain why that is needed. Okay, now let's look at variables. That to Markdown. So every line in a program with an equals sign is an assignment statement. The equals in Python and most programming languages means assign the value on the right to the variable on the left. It's not the same as a mathematical equality. You're not solving an equation. It's taking a value on the right side, plugging that into the variable on the left. So let's look at some examples of that. So let's say city equals Minneapolis. Doesn't look like that did anything, but it did. So it took the string Minneapolis, it stored it somewhere in the computer memory. Then that memory address is addressed to a label, and that label is city. So Python keeps what it calls a namespace. It's basically a lookup table, and it will have a table of the values and then the variable names that they are attached to, and also the types. If I type in the variable name here in Jupyter, it'll tell me what the value is. If I say what is its type, so type of city, str for string, so it's text as we would expect. I could say temp F. It is 79 degrees, according to my watch here. It's 79 degrees Fahrenheit today. Okay, so let's spit that back out. 79. What about the type? It's an integer. Notice that variable names are case sensitive, meaning if I use lowercase in my variable name like I did, if I then ask for temp F with a capital T, it gives me an error because to Python that is two different variables. Here's something interesting. There is a site online called Python Tutor. I'm going to copy paste some code into here and then visualize. So this will step through the program line by line. So the next line to execute is with a red arrow. And then when I press next, you see 10 is somewhere in memory, and it is given to this variable that is named X. Run the next line. So 4 is stored somewhere. It has the name Y. Okay, then line 3. These go right to left. So figure out the value on the right, and then that will be the value of the variable on the left. So first we look at the right-hand side, which is value of X is currently 10. 10 minus 3 is 7. That will get assigned to X. So X is going to be 7, and it is. You can do multiple assignments per statement, so this can be useful sometimes. So here I want to assign Y, the value of Y to the variable B, and the value of X to the variable A. So on the right hand side, XY is 7, comma 4. So A, B equals 7, 4, A equals 7, B equals 4. And it is. In line 5, looking at the right hand side, the value of Y is 4, the value of X is 7. So this is 4, comma 7. So XY equals 4, comma 7. So X is 4, Y will be 7. And sure enough, it flipped those two variables. I would recommend going to this site, make up some simple programs, play around with it for 20 minutes or so, and see what you can come up with and get a feel for it. All right, some naming rules in Python. I'll specify Python, because this is not the same in every computer language. So the first naming rule, names must start with a letter or underscore. Underscore is that character, that fill in the blank looking character. You can start variable names with an underscore, but that has a very specific meaning that we'll get to later in this series. For now, just start all your variable names with a letter. It's the most sensible thing to do anyway. After that, letters, digits, and underscores are fine. So from the second letter onward, you can use more letters, you can use digits, You can put underscores. Underscore has a particular meaning we'll get to in just a moment. Case matters. So we saw this a moment ago with lowercase temp underscore f versus capital T temp. Those are different. And by convention, use snake case, meaning that if you put two words together, like snake and case, then separate them with an underscore. That's not strictly enforced by the Python interpreter, but it is a convention. So especially when you're on a team, everybody's code should look more or less the same in terms of style, because then that's less brain space you need to think about it. So if everybody is the same, and in Python, the convention is snake case. You may have seen camel case or something in Java, but in Python, it's snake case. All right, now let's look at types. Every value in Python has a type. The type determines what you can do with it. So the type of 42 is an integer. The type of 3.14, it's a decimal number, which is known as a float. The type of string of characters is a string. Type, this one you may not have seen. When I type in true, you see it's color-coded green. So that apparently has a special meaning. And in fact, true and false are known as Boolean values. Under the hood, they're stored as 1 and 0, but the type is different. So the four scalar types, scalar meaning indivisible or the atoms of the language. See later, you can build these things up, but the scalar types, int for integers, float for decimals, bool for booleans, true and false, and string for text, which we'll get into in a later episode. Values can get rounded internally, even when you don't think they would be. So the issue here is that in a computer, values are stored base 2, so zeros and ones, rather than the usual base 10, 0, 1, 2, 3, up through 9 that we're used to. And so because of that, there can be strange little artifacts. So 0.3 does not store cleanly in binary. So just like 1/3 in base 10 is 0.3333, goes on forever. It just doesn't store very nicely in base 10. In base 2, it's a different set of numbers that don't store nicely. So 0.3 is one of them. So it has a little bit of garbage here on the end of it. So if I say 0.1 plus 0.2, double equals is asking the question, is this equal? So I'm going to get a true or false answer. So is 0.1 plus 0.2 the same as 0.3? And no, it is not, because Python is comparing 0.304 to just 0.3. I'll just say division. So with division, you always get a float. So 5 divided by 2, those are both integers. And if I divide it out, I get 2.5. Makes sense. The answer is not an integer. But if I say 4 divided by 2, 2.0, so it still stores it as a float. So division of integers, of course, division of floats as well, always stored as floats, or if you mix them. It'll be stored as a float. If you do just want the integer part, use a double backslash. That means integer division, and now I just get the 2. So 5 divided by 2 is 2, remainder 1. You get the 2, throws away the remainder. Next topic is dynamic typing. Okay, so Python is dynamically typed. That means a name, a variable name, can be bound to any type of value, and it can change in the course of a program. So if I say thing is equal to 42, okay, spit it back out, I get 42. What is the type of the thing? That's an integer. Now if I say thing is equal to 3.14, what will happen? Do you think that it will keep thing from being storing a float in what's already an integer, maybe? Some languages do that. Will it override it? What happens? Well, let's see. Okay, it didn't give me an error. And if I return it, I get 3.14 float. And the type of thing is now a float. So if we think about the way that assignment statements work, if I look at 140 up here, on the right-hand side, I have a float that's stored somewhere in memory, and then the name thing, or the thing is the name of the variable that gets bound to that value. So if it's been previously bound to something, then that's going to get blown away. And thing is now 3.14. If I change it again, thing equals hello. Okay, spit it back out. String hello and the type should be string, and it is. So the name thing in and of itself does not have a type. You do not have to declare what type it is when you make the variable. You just say variable equals something, and the type is inferred. So languages like Java and C make you declare a type up front and then hold you to it. Python is more flexible, and it figures it out at runtime. One consequence of this, if you use a name before you've assigned it, then it is not in your namespace. It's not in that lookup table. It didn't come from anywhere. And so Python doesn't know what you're talking about. So if I say my var, I guess short for my variable, then I get an error. And the error is that the name my var is not defined. So if I then do define it, my var equals 45. Try it again. Now it's in memory somewhere, and it will return that value. We can look at typecasting. Nothing to do with Hollywood in this context. You can convert values from one type to another. That's called casting. So if I have integer of 1.7, I get 1. So it just truncates, meaning it just drops to decimal. It doesn't round it or anything. It just drops it. So the integer of 1.7 is 1. The integer of true spell is 1. Float of 42 is an integer, is 42 is a float. I can do a string of 9.99. Okay. That looks like it might be the same, but it's not. So now, if I try, for instance, to do arithmetic on that, string of 9.99 divided by 3, and that doesn't go because 999 is now considered a piece of text. And what is text divided by something? Doesn't really make sense. Okay. I can also make an integer out of a string, assuming that the string contains something that looks like an integer. I can't plug just anything in there. Okay, and it figured out it was 42. I say integer of dog. It doesn't know what I'm talking about. Why would it? Okay, let's try this, see if this works. So integer of the string, the text string containing 1.1, and turn that to an integer. And that's a step too far. For that to work, Python would have to convert the string 1.1 into the float value 1.1, and then convert that into the integer, which would be 1. You can't do that in one step. It's a bridge too far. I suppose I could do integer of float of, let's see if this works. Yeah, that worked. So if I explicitly tell it to convert to a float first and then to an integer, it will do that. But you have to tell it. So thinking about typecasting, let's go back to our original program. And let's look at line 2. What's going on there? So the input is how old are you? And I typed in 29. But in the result of an input is always a string. That's just the way Python is set up. And it kind of makes sense. If I say, what is your name? Mark is a string. So, as a generic function, if you're going to ask the computer for something and get something back, string seems like a safe choice. In this case, I got 29. I was going to do some calculations with it to get how many seconds. So I can't leave it as a string, so then I had to cast it to an integer. So line 2, it gets string from the user, casts that to an integer, and then binds that to the variable age. So what we've seen is that variables are names or labels. It's often described to beginners as a box that you put something in. I guess that might work conceptually up to a point, but it's a little more nuanced than that, as we've seen. Assignment is a two-step process. So you look at the right-hand side, evaluate that, see what it is, then assign it to whatever variable is on the left. We saw the 4 scalar types, so integer, float, string, and Boolean. Dynamic typing, you don't tell Python what kind of variable you want. You just say variable equals, and it is inferred. We looked at casting, which it means converting from one type to another type. So that's a good foundation to build on. Next episode, we'll look at operators, the math module, preview of Python's collection types. We've already seen list, but we'll see more. And how to get help from within Jupyter without having to Google. Nothing wrong with Google. I Google all the time. Everybody does. But you can get help within the Jupyter interface itself. Okay, I'll put the URL for the Python walkthrough program website that we saw, and I'll put a link to the GitHub for this episode. If you like this content, please like and subscribe. Thank you. See you in the next one.